The Story of the Atom, Chapter 2, The Moving Molecules. You do not need to see molecules to know that they are always there. There are ways of knowing about things even if you cannot really see them. Look out of the window on a windy day. How do you know it is windy? You cannot see the air itself as it rushes by, but you can be sure the wind is blowing. You can tell there is wind because you see the trees swaying. You see clothes flapping on the line. Clotheslines. It was a thing before there were dryers. You see leaves and pieces of paper flying past. You can be sure that the wind is out there, pushing things around. See the wind blowing the trees, the clothes on the line, and the sailboat. Scientists can tell what molecules are doing even though they cannot see them. They know that molecules never stop moving, and they move very, very fast. If you could let a molecule race with the fastest jet plane, the molecule would win every time. But molecules do not move very far before they bump into other molecules. They are so crowded that they can move only a very tiny bit between bumps. So a molecule moves very fast, but only for a little way each time. Then it bumps into another molecule, and off it goes another way. A molecule darts and bumps, It zigzags back and forth and up and down. Each little move that it makes is twice as fast as a bullet. Here's one way to imagine how molecules move. Think of a big box with rubber balls in it. If you shake the box, the balls will fly around inside. There are so many balls that they keep bumping into each other before they can go very far. This is the way molecules keep bumping into each other as they move around. This is perfect music for molecule movement, or rubber balls in a box, don't you think? I think so too. Of course, you have to keep shaking the box to make the rubber balls move. But molecules keep going all by themselves all the time. You can make molecules move even faster than they usually do. When you heat anything, you're just making its molecules speed up. The hotter you make anything, the faster its molecules jump around. In an ice cube, the molecules stick together tightly and move very little. When heat makes an ice cube melt, the molecules loosen up from each other and begin to slide around. Then the ice becomes water. If you keep on heating the molecules move faster and faster. Soon some of them are going so fast that they jump clear out of the water. Little by little, the molecules fly off into the air to form steam. You see here, we have ice. The molecules are close together, not moving around as much. Then it becomes water, not as dense, and moving around a little more. And then when it becomes steam, they're very loosely packed, and they're even flying up into the air. So when anything is hot, it means that the molecules are moving faster than usual. You can tell how molecules in water are acting by the way the water looks. If the water has become hard as ice, you know that the molecules have slowed down. When ice melts and becomes water, you know that the molecules are sliding around. If there is steam going into the air from water, you know that many of the molecules are darting away. End of chapter 2.